Welcome back. In part 1, we learned about cookie-based authentication in ASP.NET Core and discussed the difference between authentication and challenge. Today, we're going to investigate the challenge portion a bit more, so stick around. If you recall, in our sample application, we created a custom login page with a username and a password, and we hard-coded the validation in the controller. In other words, we had no database behind it. This would not be good enough for a real application. In fact, there are a number of issues you would really need to address to make it robust enough to use. For example, one-way encryption or hashing of the password in the database, password changing and reset options, recovery options, multi-factor authentication options such as SMS and biometric security. Because this can add more complexity to your app if you have to build it in, it is better to delegate that responsibility to a library or a service outside of your project. This way, your project can focus on doing what it was designed to do and not worry about user management and identity. There are many identity providers available, and most of them offer free services or free tiers. Google, Facebook, Twitter, Microsoft, GitHub are a few. Commercial providers such as Auth0 and Okta are also very popular and offer free tiers. There are several ways to use an external identity provider. Some examples include SAML authentication, Auth 2.0, and OpenIdConnect, which is really just an extension of Auth 2.0. Today, I will focus on OpenIdConnect. First, let's use Google as our identity provider, as it's one of the easiest to use. You may need to set up a developer account in Google. I don't remember, as I've had one set up for many years now. So navigate to console.developers.google.com. I think if you just have a Gmail account, you should be able to accept the terms and conditions and have access to this dashboard. From this dashboard, I have a few things, but I'm going to go ahead and create a new project. And we'll just call this Auth Sample Project. And you can attach it to an organization. Okay, now that our project has been created, I want to switch to it. So I'm going to switch to Auth Sample. Now I'm going to go to Credentials. I don't have any credentials in here, but what we're going to do is create one. So I'm going to say Create Credentials, and I'm going to create an OAuth client ID. To create an OAuth client ID, you must first set a product name on the consent screen. So we're going to set it external to our organization. It means anybody with a Google account will be able to log into our app. As you see, there's 4 steps that we'll need to complete. We need to fill out the application name. It's requiring me to put a support email. If I had an app logo, I could put one in. If we were going to host this application, we would need to have it on a specific domain. We'll be running it as localhost, so we don't need to fill out all this information for now. If we were going to publish it, though, we would need to do that, and we would need to add an authorized domain. And then it's requiring me to put a developer contact email address. The next thing it wants to know is certain scopes. Scopes express the permissions you request users to authorize for your app and allow your project to access specific types of private user data from their Google account. All right, so what does this mean? When we're talking about scopes here, because we've delegated this responsibility of managing user identity over to a third party, in this case Google, Google has lots of information about you, more than you think. But they have all this information about you or a user. If we want to use their authentication system, we need to ask specifically for the pieces of information that we need for our application. That's what this is all about. So to add or remove scopes, we just click this button. And here are the 3 pieces of information that Google is willing to give us. The user's email, their profile, and then their OpenID. And their OpenID is a unique key that represents them. So I'm going to select all of those because I want them all. So sensitive scopes, I haven't asked for any sensitive or restricted scopes. There's a lot more we could ask for. For instance, we could ask for access to their Google Drive, to their Google Photos, if our application needed those types of things, but we're not going to do that for now. Here's some optional info. I'm not going to put anything in here. And finally, the summary screen. If everything looks good, then we'll go back to the dashboard. Now we should be able to get our credentials this time around. So we're going to create credentials, an OAuth client ID, and we're going to set the application type. So OAuth will work for a lot of different types of application. Today we're just doing a web application, but you could create a Windows UWP application, a desktop app, or an iOS or an Android app. Today we're going to just choose web application, and we'll just leave it generically, how about we call it sample auth client. Good. All right, so we also need to add a callback URI, and this will make more sense in just a second. For now, since our application is running on local host 5001, I'm just going to have it call back to auth. So now we've been given a client ID and a secret. So we'll want to capture each of these. So I've copied both of those, and we'll need those in our application in just a minute. Here's a little pro tip. If you're on Windows 10, you should enable the clipboard history. Use Windows plus V to access the clipboard history. This will save you multiple trips when copying. Additionally, if you enable syncing of clipboard history, you can copy and paste between your devices, for example from a laptop to a desktop or vice versa. We want to connect our Google credentials. To do that, we'll need to go to the startup, and we're going to add a handler in here, but before we can do that, we need to grab it from NuGet. So I'm just going to go right-click, Manage NuGet Packages. And I'm going to search for Microsoft.ASP.NET Core Authentication. And we'll see several items come up in here. But the one I'm looking for is this one, Google. And we'll go ahead and install that. The latest version should be fine. To connect this, we're going to just chain off the end of cookie. And we're going to say add Google. There's some options we'll need to pass. One of the options will be our client ID. We'll paste those in. And our client secret. And our callback path, which when I registered it, I set that to /auth, if you recall. Now I'll go to my clipboard history, and I'm going to paste in the client ID, and I'm going to paste in the password. Normally, we would put these in the user secrets file and use the configuration manager to get those values back out. But for simplicity's sake, I'm just going to hard code those in here so we can see this work. We need to do a little bit of changing here in our overload for add authentication. Before, when we passed this cookie authentication scheme as the default, it was the scheme for everything. Because we have now 2 authentication handlers in the system, we need to be a little bit more specific about how we define things. So we're going to be specific, and we'll set a default scheme, and that's going to be our cookie authentication defaults.authentication scheme. However, we are now specifying a different challenge scheme. So I want to set the challenge scheme. We're going to configure the Google account to be our challenge scheme. There's one more thing I need to do. We need to remove this roles property from the authorize attribute momentarily. We're just not ready for it yet. We'll put it back in later, but for now, I simply want to say if you're logged in with a Google account, then you're authorized to hit the secured endpoint. I believe that's all we need. So let's go and run this and see what happens. Click on secured. Now we're at a Google prompt. Sign in with Google to our application, Auth sample. And I've created a test account that I'm going to put in here. But let's just read this. It says, to continue, Google will share your name, email address, language preference, and profile picture with Auth sample, our application. So this is what we call the consent screen. By signing in on this screen, I'm giving permission to this application, Auth sample, to receive this information from Google. Okay, now that we've signed in, Google has given us some information. It's given us the name, Bob Tester, and it gives it to us in given name and surname is Bob and Tester again, and his email address is bob@mnemonics.com, and his name identifier is this. This is the OpenID, or a unique identifier that Google is providing for Bob Tester. Now, if you recall on the consent screen, it said it was going to give us a picture, but I don't see a picture in here for a photo for the user. We'll have to go figure that out later. But for now, it works, and we've gotten this information from him. But it's all been a little bit magic. I promise we'll unravel some of the mystery in a moment, but let's check out Logout first. Remember, we didn't make any changes to that. It seems to have logged us out. Now, if I click on Secured again, we'll see what happens. And we're logged right back in. In fact, we didn't even get a prompt. Let's look at the developer tools. Specifically at the Application tab under Cookies and our local host, we see that we have an ASP.NET Core Cookies. That represents our logged in state. If I click Logout, it clearly takes the cookie away. However, let's go to accounts.google.com. Now, if we go to accounts.google.com, Google still believes that I'm logged in, which I am. So I'm logged in with Google, even though I've logged out of the application. So if we go back to our application, we'll watch the Network tab this time. I'm going to clear this. I'm going to click Secured, and this is going to happen pretty fast. Notice I have Preserve Log checked. What happened is we bounced around a little bit. When I click Secured, because it's protected by the Authorize attribute, it says you're not logged in. It performs a redirect, a 302 redirect. If you can see this, let me see if I can make this a bit bigger. So if we look closely, this particular request to our server results in a 302 redirect. It gets the instruction to redirect to this location, which is this location here, accounts.google.com, as you can see. Now, accounts.google.com would normally throw up a login page or a login prompt. However, since I'm still logged in at google.com as Bob, it says you're already logged in. I will just redirect you back to the auth endpoint. So if we look here, it's saying 302 redirect, and it says where? I'm going to redirect back to localhost 5001/auth. That's the callback URL that we pre-registered with Google. In other words, we said, hey, when you're done, call us back at this endpoint. We will be listening, which we are. And we receive some information here. Then it redirects back to the original page that we were headed to, the secured page. So that's kind of that's the trail. So far, we registered an application at the Google Developer Console. We received OAuth 2 credentials so our app can use Google as the IDP or identity provider. We imported a NuGet package from Microsoft that makes connecting to Google very easy. And we connected and tested the handler to see if it works. What exactly is a handler, and how does it relate to authentication middleware? It can be helpful to think of the authentication middleware as a general contractor who is in charge of building a house. The general contractor understands the blueprints, how everything fits together, and establishes rules for the subcontractors to follow and integrate with. Subcontractors are specialists who understand their area of expertise. They might be experts in plumbing, electrical, or even window installation. Likewise, the authentication middleware is like the general who knows the blueprints, how it fits, and sets the rules. handlers are subcontractors or specialists who understand different parts of the authentication process. Cookie and JWT handlers take care of creating and validating the tickets on each request, while the OAuth and OpenID handlers control the challenge schemes. This subdivision of labor creates a flexible framework that can be mixed and matched according to the application's needs. Returning to our app, I wanted to investigate the logout behavior. Remember when I click logout and then I return to secured? And it just logs me right back in because it made a quick trip to Google, recognized that I'm still logged in with Google, and just let me right into the app. Now that may be a desired behavior, but what if we wanted to let the user choose a different Google account to log into? Returning to our Startup.cs file, there's an option for the authorization endpoint, which if we append on to the authorization endpoint, a prompt equals consent, that will instruct the authorization endpoint. It will prompt them to select or allow the user to select a different user from the consent screen. So let's add that and see what happens. I'll click Logout and then I'll go back to secured. And this time I'm prompted to select an account. Now I can just choose Bob Tester or I could use another account. In this case, I'm just going to go ahead and log in with Bob Tester. And I'm logged in again. So that works good, but what if I were on a public machine or a public computer and I logged in? If I clicked log out, I might expect that I would be automatically logged out of the Google account as well, but that is not the case. This is a good reason to use in private or incognito windows when you're on public machines. Tip for the day. The OAuth 2 and OpenIdConnect specifications don't provide a standardized mechanism for logging out of the IDP or the single sign-in provider like Google, but I can show you how to do it for Google, and the pattern will probably apply for other providers as well. To accomplish this with Google, let's go to the home controller and let's go to this logout. Currently, after we sign out, this HTTP context sign out async, it's only signing us out of the default scheme, which is the cookie authentication scheme. So it's doing that part really well. It's removing the cookie and it's making the user session end. But when we're done, we just return back to the home page again. If we want to log out at Google as well, then we need to redirect to Google. So I'm going to replace this one with this. And we'll try to break it down here. So what we'll be doing is redirecting to Google's IDP logout URL. And then they have a continues equals, and you need this for some reason. You need to go to appengine.google.com and also log out. And then when you're done, this last continue tells it where to return to when we're done. In other words, come back to our application. Now you could send this anywhere, it doesn't have to come back to your application, but in this case, that's what we want. Let's move that back to one line. Now let's run it and see what happens. So now when we redirect to Google, we get this notice that the previous page is sending you to localhost 5001. Now it takes us back to our application. Now when I click secured, click on Bob Tester, it prompts me for a password, which is great. Returning to our code, I think that's as much as I want to do with the add Google handler, and now I want to switch to using a generic OpenIdConnect handler instead. First we'll need to install a NuGet package from Microsoft, ASP.NET Core Authentication, and we are looking for OpenIdConnect. So I'm going to leave the add Google down here for just a second. Let's add OpenIdConnect. And we haven't done this in the past, but I'm going to give this a specific name. Google ID, how about we call it Google Open ID. And then we'll configure the options. And we'll need the same options as we have here. We'll need to change our challenge scheme from Google to Google Open ID. And because we've left this add Google in here, it's going to cause a problem. Notice that they're both listening at the same callback path. It's going to be confusing which handler is actually supposed to listen to this route and complete the call. So at this point, I'm just going to comment this one out so we don't have a collision at that location. And then put my semicolon. One other thing that is needed here is for us to specify something called the authority. All right, let's run this and see what happens. Okay, and now it logged us in. And our logout should still work the same. And it does. If you remember earlier, we never got a picture or photo for the user. Now that we're using OpenID, we are. Notice this. And there's the photo. This could come in handy for our application if we want to display a small avatar or an image of the user who's logged in. So what's the big difference between OpenIdConnect and the Add Google handler? Remember, the Add Google handler is built on OAuth 2.0, and while OpenIdConnect extends OAuth 2.0, there are a few differences. What you don't see inside of the Add Google handler is there's a number of endpoints that need to be configured. Besides the authority, which is also embedded in there, it also needs to know where the token endpoint is and a couple of other important endpoints. And those are configured, hard-coded inside of that Add Google endpoint. OpenIdConnect takes a slightly different approach. They use an endpoint called a well-known endpoint where they publish the other endpoints that are needed for the OAuth mechanism. We can take a look at that now. If we go to accounts.google.com/.wellknown OpenID configuration, this is a common endpoint for OpenID servers. .wellknown/OpenID configuration. If you go to this endpoint, you receive a JSON file with key endpoint information and other information located in it. If we take a look here, you'll see things like the authorization endpoint, the token endpoint, user info endpoint, and this JWT URI. If the endpoint were to ever change, for instance, the user info endpoint to something like a v2, you wouldn't have to go and update that in your code because the configuration is discoverable. The JWT URI is an important one. If we click on this one, what you will find in here are keys, asymmetric keys. These keys are used to verify and validate the token that is sent to you. Now, we haven't talked much about the token yet, but let's spend some time and talk about that. Let's return to the home controller. In our secured action, I want to get the ID token, and the way we do that is by calling getToken async and ID_token, and it is async, so let's do an await and convert this to an async method and return a task of iActionResult so we can make that work correctly. Okay, so this will get the token off of the context. Now the token will only exist on the context if we, in Startup, tell it that we want to save tokens. And what they mean by save tokens is the token that we get from Google, which is an ID token, isn't automatically saved in the cookie. By setting that to true, we will save that token in the cookie. Now this is going to make our cookie larger, fairly significantly larger in fact, but if we need access to the tokens for some reason, then we have to do this. Now let's set a breakpoint in our controller and run this and watch what happens when we get the token. Okay, if I hover over the ID token, I get one back. And there it is. So this token is in the form of a JWT or a JWT token. And let's learn a little bit more about JWTs. JWT or JSON Web Token, often pronounced JWT, is a token that uses JSON notation to embed authentication and authorization claims for applications. A JWT is made up of three parts: header, payload, and a signature. The header contains information about the type of token it is, JWT or JWT, and the algorithm used to encrypt the signature. The payload contains the auth claims. The signature is an encrypted block of data which will be used to verify the token's authenticity. The three parts are separated by a period character: header, period, payload, period, signature, making it easy to parse. The first two parts, header and payload, contain base64 URL encoded JSON data. The signature is encrypted with asymmetric keys, meaning that you can use a key from the IDP to verify the signature, but you cannot use those keys to create your own signature. This is important to provide security to prevent tampering of the payload data in a token so the data can be trusted by a consuming application. Let's grab this token and let's go to a website called JWT.io, crafted by Auth0, and we'll paste it in to this location. And you'll see that this website automatically decodes this for us using base64 URL decoding. We can see what's in the header, and we can see what's in the payload, and we can see that the signature is verified. Now the way that it did that is it had to go and get the public key that's available. That public key it found by looking at the issuer, going to the well-known endpoint, going to the JWK URIs, the JSON web keys, finding the key that it needed that matched this KID to verify that this signature is valid. So this website did all of that automatically, and your application can do the same thing. Now I want to demonstrate. Let's pull out the payload section, and I'm going to go to Revolt.js website, go to one of their utilities, go to the base64 URL decoder. I'm just going to paste this in here, and it always puts an extra space. Whoops. They take care of that. They trim that on this website. So now I have the JSON from this. So what I want to do is show what happens if we try to modify the token in any way. So I'm just going to try and change Bob's last name from Tester to Jones. And then I'll copy this back out. And I'll go to the encoder page. And again, paste this in and encode it. And you can't tell, it's a little bit different, but it has changed it. So we will find out what happens now. So if I copy this and I just paste over this purple block, can I do that? Will it let me? It will let me. Okay, so now the website has the new data and it decoded it, and you'll notice that it decoded the payload properly. Now it thinks it's Bob Jones. Now you might think that's scary. Wait a minute. If somebody can just modify their token, or some bad actor can get in there and modify their token, wouldn't that be a problem? Well, look at what happened here. The signature is no longer valid. Because the payload has been modified without the signature being updated, it now declares this token as bad. So that's the protection that's built into JWTs, is you can't really modify this. And so long as you're checking the signature to make sure that that token is valid, you should be fine in these, and you can trust the payload. The next obvious question is, why do I even need a token? And the reality is, you don't necessarily need the token at this point. The token was important during login so that you could get the data about a user in a trusted way from a third party, in this case Google. Once you receive the token, the handler extracts the claims from it, and it puts those claims into a ticket that then gets encrypted into a cookie for you. And really, you have access to those claims throughout the session, so you don't really need access to the token any longer. However, there are scenarios, especially in enterprise, where you may want to pass that token to another service or a microservice. In that particular instance, it becomes handy to have that token. So you'll have to decide for your own application whether it makes sense to turn this save tokens on or not. It does increase the size of your cookie, so if you don't need it, then don't put it in. But if you do need that token and want to pass it down the chain somewhere, then set save tokens equal to true. One final thing I want to do is go back to our home controller and implement roles once again. We turned that off temporarily while we were connecting Google because we didn't have that set up. But let's go back and reconnect that. Just like we did with cookie authentication, we can do the same thing here and add an event. The events for the OpenIdConnect handler are a little bit different than the ones for cookie. We have quite a few more things in here. Access denied, authentication failed, authorization code received, message received, to identity provider for sign out, on remote failure, remote sign out, signed out callback direct, ticket received, token response received, token validated, and on user information received. There's probably a couple places we could put this, but I think I want to do it on token validated. Hopefully that's correct. We will see. Okay, and for now, I'm just going to, I need to take a peek inside of the claims and see what that looks like. We'll go to the principal, get the list of claims, and let's put a breakpoint here, and we'll inspect that. Let's run this. Okay, I'm going to hover over claims and we'll inspect this. Hopefully you can see this. I wonder if I can make this bigger. All right, it's pretty small, but in here there is the type, which is the name identifier, and then here's the value. So I'm going to grab this back out. So this is Bob's unique OpenID, his identifier that uniquely identifies him from Google. What I really want to do is just put an if in here and said if context.principal.claims.first or default, let's see, for claims, where c.type equals claim types dot name identifier. Then we want dot value equals. Okay, if it equals that value, then we know it's Bob, regardless of what his name says, even if it says Bob Jones now instead of Bob Tester. And we trust that key to be very unique. Even if he went back and changed his name, we would know it was him. So what we want to do is we want to create a claim. And we want the claim types dot role, and we're going to make him an admin. And then we have to attach it to his principal. And at this point, if I were to try to do this, let me try that again. So what we need to do is I'm going to change this. So if you tried to just go to context.principal.identity and tried to add a claim, there is no way to add a claim on that. What we need to do is create a claims identity Well, you can't see that. Anyway, you need to cast it as a claims identity. Then you can take the claims identity, and there's an option to add a claim, and we'll just add that in. Now, when we run it, it should let us all the way through. Okay, so now it's let us in here. When we look at his page, he has this additional claim for admin. Okay, so that worked pretty well. We have covered a lot in this video. We learned a bit about OpenIdConnect, JWTs or JSON Web Tokens and their structure. We connected our app using the Google handler and a generic OpenIdConnect handler to Google, and we re-implemented our authorization using the OpenIdConnect events. There is still a lot to understand about OpenIdConnect and something known as OAuth grant types or flows. We will look more into flows in our next video when we connect a second IDP, Okta, into our application. We will demonstrate how to allow multiple providers for people to choose from when logging into your application. If you have any questions or topics you would like to see covered, please leave me a message in the comments section. And as always, thanks for watching.